This is the instructional video for the SPSS practice sheet, which we have done in the lab, but some of you would like some extra review. So I'm going to work through the SPSS practice sheet, which will cover all the different types of tests that you would need to do for the final test. The first thing that you need to know is how to select cases, which is found here on the data tab. But let's start by bringing in our data set. You can either go to the class website and go to the files page, and I think it's third or fourth from the bottom, and download it and then open it. Or you can go to File, Open, and then Data. Mine is, I believe, saved on my desktop. This is it. It's the Santa Fe. Okay, and there's the data set. All right. So the first thing we would need to learn is how to select cases. When we go to do this, we'll go to Data, Select Cases, and then this is used to meet a certain condition, if a condition is satisfied. So let's, even though it's the first thing on your sheet, the first question does not involve it. So we'll wait until we get to a question that involves those types of select cases questions, and then we'll learn how to actually do it. All right, the first thing that we do is frequencies and descriptives. So we've talked about in class that frequencies are oftentimes percentages. In regards to the ability of respondents to recall television ads promoting Santa Fe's opening date, what percentage of all respondents recall ads, and what percentage of the respondents do not recall ads? We're currently looking at the data view, so we have no idea which of these variables, which are the columns, we have no idea which of these columns has anything to do with recalling ads. So we need to come down here to the bottom left and select variable view. We can make our label column wider, and we can look for the variable that talks about recalling ads. I don't see it yet. Let me scroll down. Oh, ad recall. There it is, X31. So X31 is recall ads. I can even look to see what the different values represent. If I click on this box and then click on the blue, it shows me a 0 means do not recall ads, and a 1 means that they do recall ads. All right, so to do a frequency and find out the percentage, I would go to, you can look on your sheet and follow along, Analyze, Descriptive Statistics, Frequencies. And once I'm here, I go down to Recall Ads, which was X31, and send him over into the variables box. I then click on Statistics, and I just need to know the percentages, but this is where you can see I could also ask for a bunch of other things. I hit continue, and I make sure that down here it says display frequency tables. Make sure that's checked and hit OK. Now my output shows a total of 405 respondents, 270 do not recall, 135 do recall, and that translates into 66.7% and 33.3%. So that is how you would do a frequency. I'm going to move on, not to the next question, but to the next section, starting with of only those respondents who had most recently eaten at Jose's. So to get out of this output is a running output. It'll just give you your answers every time. You can close it at any time. Save contents of output. No, I don't need to save those. And now I'm just back to my data. All right, so this question starts by saying of only those respondents who had most recently eaten at Jose's. That's your signal that you're going to select cases if it says of only those respondents. So we want to look at those respondents who had only most recently eaten at Jose's Southwestern. If we come up here, we can see that there's a question that says, or an item, Mexican restaurant most recently eaten at. If I look at my values, the options were Jose's or Santa Fe. You would want to make a little note on your paper that a 0 equals Jose's. You would actually write this down so you can remember, and a 1 equals Santa Fe. I then follow my instructions for selecting cases so that I'm only going to be looking at respondents who had most recently eaten at Jose's. So let's go back up to the top of the sheet and follow the steps for selecting cases. I go to Data, Select Cases. If a condition is satisfied, hit If. All right, now we want to only consider people if they ate at Jose's. So I would go to the Mexican restaurant most recently eaten at, send him over, and this variable would need to equal 0, which is what we wrote down for Jose's. 0 equals Jose's, 1 equals Santa Fe. So if they have a 0 in this column, then it means that they most recently ate at Jose's. If we were looking at people that had eaten at Santa Fe, we would do a 1. We are interested in Jose's, so we do a 0. And hit Continue. OK. You can just minimize your output there. And if you go back to your data view, you scroll down, you'll see that a bunch of people are crossed off here on the left, which means that they did not meet that condition. So their data is not being used for this. So now we've taken care of that first part of only those respondents who had most recently eaten at Jose's. Now we move on to the next part. What was the average likely to return? Average likely to return, that's asking for a mean. So we'll just follow the steps. We'll go Analyze, Descriptives, Frequencies. We don't care about add recall anymore. Now we care about the average likely to return. And here it is right here, X23. Send that over. Statistics box. This time it's asking us for the average, so we'll check mean and the range of scores. We look down here, here's range. Now just thinking ahead, because I'm only going to do this one question from this section, the next question is asks about the mode. So this is where you would also find that kind of information. Right here is where you would check it to find mode. This is where you would check the box to find mean, median, mode, standard deviation, the minimum value, the maximum value, and the range can all be checked here. Continue. OK. And we can look right here and see that for the variable likely to return, the average was, well, that little box is in my way, 4.96. Mean is 4.96. All right, let's move on to the next question. Anytime we select cases, I'm going to close this. Anytime we select cases, we need to go back and clear that option so that for the next question we start fresh. Otherwise, it will only be considering Jose's people from here on. We want to make sure that we're back to considering everybody. So we go to Data, Select Cases, and then click on All Cases so that we're now considering everybody again. Anytime you get the output, you can just close it when you're done with it. All right. Of all respondents, describe the relationship between likely to return and likely to recommend. All right, so for this one, it says of all respondents, so we know we're not skipping or selecting cases. We would go to Analyze, Correlate. So now we're just doing a correlation. Bivariate, so correlation of two variables. At any time you can't see things, you can just stretch the box out a little bit like that and make it so that you can read all your variable names. And this time we are going to do a correlation of likely to return. Here it is. Send him over. And likely to recommend. Send him over. You can see down here at the bottom, in class we talked about Pearson and Spearman. Spearman is used for ordinal data. We're doing interval data, so this is Pearson's. We're going to leave it two-tailed, and we hit OK. And if we cross this row, which is likely to return, with this column, which is likely to recommend, we see that our Pearson correlation is 0.844, which is significant, less than 0.05. And we know that 0.844 is a strong positive correlation, a strong positive relationship. So you could, for the next one, you could do the same thing for speed of service and satisfaction. Okay, we're going to turn the page and move on to a one sample t-test. A one sample t-test is when we compare a mean to a test value. You would be given that test value. You would know to do a one sample t-test because you would be given the number to use. I'm going to close out of my output. All right. Of only those respondents who had most recently eaten at Santa Fe Grill. That's my cue. I need to select cases. Data, select cases. If a condition is satisfied. And this time, instead of Jose's, which was a 0, we're looking at Santa Fe. So we would change our 0 to a 1, which was the code for Santa Fe. Continue. Okay. All right. Now I can just get rid of that. And you can see that certain customers are certain respondents are crossed out. Their data is not being included. I can now move on to the rest of the question. Was the average likely to return different from the expected value of 5? I'll go to Analyze, Compare Means, One Sample t-test. I'm going to make this bigger so I can see what I'm doing. All right, likely to return. It's down towards the bottom. There it is, X23. Now this time I'm going to come down to this box that says test value. And the value I'm testing against is an expected value of 5. I just type in a 5 there. Okay. And here we go. For likely to return, the mean is a 4.17. So it sounds like it is different from the expected value of 5. It's lower. But we need to see if it's significantly different. So we come down to this box where we see the significance. It is less than 0.05, so we know that the average likely to return is significantly different from 5. And in fact, it is significantly lower because 4.17 is less than 5. Let's do the next one just to make sure you got it. We'll close that. This time of all male respondents. All right, so I'm going to clean out I'm going to go back to all cases, clean that out. Now I need to go figure out how to know males versus females. I can go back to variable view, find the gender. Here it is. Look at what my codes are, and I'm going to write it down on my my paper, so I don't forget. A 0 equals male, and a 1 equals female. So now I can just hit close, go to data, select cases. If a condition is satisfied, if. Now this time I can delete all of that. I want to know if gender is equal to 0. 0 was the code for male. I hit continue. Okay. Now if I were to go look at my data view, I can double check and look at all these crossed out rows. These are respondents that have a 1 in that column. I only want people with a 0 for male. So it has crossed off all the females. Now I can move on to the rest of the question. Was the average perception of reasonable prices different from 3? I'll go to Analyze, Compare Means, One Sample t-test, get rid of what's there. I now need to know reasonable prices if it's different than 3. Okay. All right, it turns out that the average for reasonable prices is 4.36. It seems like it's higher than 3, but we need to make sure it's significant. It is significant. It's less than 0.05. So the average perception of reasonable prices is significantly different than 3. In fact, it's significantly higher. Okay, let's do the paired sample t-test. I'll close this, and I'm going to go back to select all cases. Since I've been messing around with it, I want to make sure I get a fresh start. Okay. No, I don't need to do that. Of all respondents that drove less than 1 mile, the likelihood to return will be greater than the likelihood that they will recommend. So I'm looking at one big group here, but 2 outcomes, likelihood to return and likelihood that they will recommend. The first part says of all respondents that drove less than 1 mile. So we're only going to be looking at a certain group of people, but we don't know what that is yet. So let's see. Distance driven to restaurant, we want those people that drove less than 1 mile. We look at the coding here. We would write down on our paper, a 1 equals less than 1 mile, a 2 equals 1 to 5, and a 3 equals more than 5. Okay, I now go to data, select cases, if a condition is satisfied, and I'm going to send over the people based on distance driven, and I want the people that drove less than 1 mile, which was coded as a 1. If you were interested in the people that drove 1 to 5, you would have put a 2 here. If you're interested in the people that drove more than 5, you would have put a 3. Continue. Okay. We can double check it. We can go back to our data view. And yep, there's a lot of people crossed off. So it's only showing us people that drove less than 1 mile. Like this person right here drove less than 1 mile. All right. We would go to Analyze, Compare Means, Paired Samples T-Test. And the two things that we're going to be comparing are the likelihood to return and likelihood to recommend. We're going to send over likely to return and likely to recommend. You want to make sure that these show up next to each other. We're leaving the second pair empty. We don't have a second pair. We're only comparing two things here. And if something does end up popping into this box here, you can just highlight it and send it back. So if for some reason that ends up happening, you just click on it and send it back. It's no big deal. All right, then we hit OK. There's a lot of information here. We see that the mean of likely to return is 4.91 and the mean of likely to recommend is 4.32. The hypothesis was that likelihood to return will be greater than the likelihood that they will recommend, and it does look like it's greater. We want to come all the way down here, though, to find out if that's significant. It looks like it is significant. It's less than 0.05. So yes, the likely to return is greater, significantly greater than their likelihood to recommend. If you look at this second big chunk here, this is the correlation. It's telling you that this is the paired sample correlation. Don't get confused by this significance. This is telling you that these are correlated at 0.535, which is positive, and that correlation is significant. It has nothing to do with the actual t-test, okay? You want to make sure that you're looking at this significance here. All right, we're going to go on to the independent samples t-test, the next group here. So I'm going to go back to select all cases, make sure that I'm looking at everybody. After each one, you want to make sure that you go back to all cases. Even if you end up having to redo the exact same scenario, you just want to make sure each time you start fresh. Among all respondents, so I know that I want all cases. I don't need to select anybody. The customers who most recently ate at Santa Fe's will be more likely to return than those customers who ate at Santa Fe. I'm looking at two groups here, the people who ate at Jose's and the people that ate at Santa Fe. And I'm comparing them on their DV, which is likely to return. I'll go to Analyze, Compare Means, Independent Samples T-Test. I'm going to make this bigger so I can see what I'm doing. Okay, the test variable is my dependent variable, and that is going to be their likely to return. So I go to likely to return and put him in the test variable. That's what I'm testing. That's my dependent variable. But this time I'm comparing these two groups. My whole data set is considered to be into two groups, the people that ate at Jose's and the people that ate at Santa Fe, which was based on this variable here, Mexican restaurant most recently eaten at. I send him into this box here, the grouping variable. I then need to define the groups, and we already wrote down that group 1, the Jose's, were coded as a 0, and the second group, Santa Fe, was coded as a 1. I hit continue. Okay. So if it was asking you, if it had asked you the exact same question, but using comparing males and females rather than Jose and Santa Fe, your grouping variable would have been gender. And again, your groups would have been coded as a 0 and a 1 for male and female. Okay, now we can see that the mean for Jose's is 4.96. The mean for Santa Fe is 4.17. And we can come straight down and see that those are significantly different. And the hypothesis was that the customers who ate at Jose's will be more likely to return than the customers who ate at Santa Fe. And that looks like, yes, they are significantly different. The people that ate at Jose's are significantly more likely to return than the people that ate at Santa Fe. So there's a couple of those there. It looks like some of them you need to select cases and some of them you do not, so you can get practice doing that. The next big test that we do is an ANOVA. I'm going to close out of this. We're now looking for variance among the different levels of one independent variable for one outcome. The first hypothesis in this section says, for all respondents, satisfaction will vary by levels of the respondent's age. If I go down here to my variable view and I look at age, I can see that there were 5 different levels here. So people didn't just type in their age. They actually selected one of these categories, which is pretty common for a survey. So we're going to see if there's variance among these different levels. Now remember, ANOVA is not going to tell us which ones are significantly different. It's just going to tell us, is there variance among the different levels? So we'll go to Analyze, Compare Means, One-Way ANOVA. I'm going to make this bigger so I can see. Okay, so my dependent variable here is satisfaction. I'll scroll down. Here's satisfaction. And my factor, my independent variable here, is age. I'll send age over. And now I say OK. All right, and we can see just based on the significance that yes, there is variation among different levels of respondents' age. This is telling me that there is significant differences among levels of respondents' age. If you wanted to find out a little more information, Analyze, Compare Means, One-Way ANOVA, we could have hit Contrast. I take that back. You can do post hoc, and you can do some of these tests that we talked about in class. On one of your slides, I think we talked about Tukey's and Chaffee, and so that there's extra tests that can be done to then go back and find out where those different variances exist. Is it the young and the old? Is it the second and the third level, the second and the fourth level? For this class, we're not going to do that. All you need to know is if this is significant, if the ANOVA is significant, then there is variance among levels of age. All right, and now we are moving on to the regression. We have a bivariate and multivariate. The first hypothesis in the bivariate group says among all respondents, as the perception of friendly employees increases, will likely to return increase. Well, among all respondents means that we do not need to have any selected cases, so let's make sure we're on all cases. That's good. Okay, now we're going to go to Analyze, Regression, Linear. Okay, our dependent variable here, as the perception of friendly employees increases, likely to return will increase or increases. So our dependent variable that we would be predicting is likely to return. I'm going to make this bigger so I can see. Likely to return. That is our dependent variable. And what factor we're using to predict that is the perception of friendly employees. That's a new one, so let's look for that. Friendly employees. Ah, there it is. That goes into our independent box. I'm going to go to statistics here and just see if there's anything else. I don't think you're going to need any of this. Let's get in the habit of checking R squared change, but you're probably not going to need it. Hit continue. Those are the only two things you need to fill in here. The dependent variable, likely to return, the independent variable, friendly employees. Hit OK. All right. Now you should recognize these outputs from the slides that we've been talking about. Okay, so our predictor, our independent variable, was friendly employees. Our dependent variable was likely to return. We can see that the R square here is 0.130, so 13% of the variance and likely to return can be explained by their perceptions or their scores for friendly employees. Oh goodness, there we go. I have to slide all the way down here. Now we can come down here, and because we're doing bivariate, we look at unstandardized coefficients B. Here's our constant, and here's our coefficient, 0.329. And we can see that the overall model is significant. So this tells us that, first of all, 13% of the variance and likely to return can be explained by friendly employees. Second, that is significant. So this is a significant model. It's safe to make predictions based on this. Then when we fill in our formula, we write our formula, we would say that likely to return is equal to 3.265, our constant, plus 0.329 times the person's value for friendly employees plus E. All right, so that is using one factor, friendly employees. I don't need to save that, but let's move down to the next group, which is multivariate regression. So now we're predicting a dependent variable with many independent variables, many factors, at least two or more. So the first hypothesis here says for all respondents, the factors factors about what I eat and eat balanced meals predict satisfaction. So now we're looking at two different factors here. And there's a question mark at the end of the hypothesis, which that would never happen. So you can just change that to a period there instead of a question mark. All right, so let's go ahead and do this one. We go about it pretty much the same way. Let's make sure that we're considering all respondents here. Yep, all cases. All right, now we move on to the next part. Analyze, regression, linear. So whether you're doing bivariate or multivariate, you still go about it the same way in terms of getting to this box. You still just do analyze, regression, linear. Now this time, our dependent variable is satisfaction. We want to know if we can predict satisfaction. Our independent variables, we have two this time. Careful about what I eat. Here it is, X10. And eat balanced meals. Here that is here. Eat balanced, nutritious meals. We put them both in the independent variables box. Then we hit OK. So if you have 2, 3, 4, 20, you can have as many things in that independent variables box as you need. All right, we'll come on down. We can see that the R squared is 20.276, so 27.6% of the variance in satisfaction is explained by these two variables, eat balanced meals and careful about what I eat. I see that this is significant. It's less than 0.05, so these are good predictors, and I'm safe to keep going and make predictions based on these numbers. Now, because this is multiple regression, I look at the standardized betas rather than the unstandardized. So now I'm looking over here. To fill in my formula, I would say that satisfaction is equal to the constant, which is 7.255, plus, in this case, it's a negative 0.44, so it's actually minus 0.44 times their value for careful about what I eat, and minus 0.105 times their value for eat balanced meals, plus E. And I can come over here, if I was asked, are both of those significant predictors? I can look and see that careful about what I eat, that beta is significant. So he is a significant predictor. However, eat balanced meals on his own, he has a significance of 0.091, which is greater than 0.05. So on his own, he would not be a significant predictor. However, these two things together still do predict satisfaction. Just independently, this factor here would not. All right, so that is the SPSS practice worksheet. You can go back to any of these hypotheses to see how to run the test based on this video. And we have gone over most of this in class so that you have plenty of practice doing that. You're welcome to work with people in your groups to make sure you understand it. Thanks.